Hello everybody, and welcome to the Unit 8.3 video, which is about synthetic division, which some students prefer over long division, but unfortunately only works in certain circumstances, and we'll talk about that. But it's another way to long divide, so it depends on the situation, I guess. So I would rather than going through this start thing, all you need to know is that synthetic division is a shortcut for long division. However, synthetic division can only be used if you are dividing by a linear factor. What I mean by that is if you're dividing by something like x minus 5. This is x to the first, so it's linear. Synthetic division does not work if you're trying to divide by a quadratic. Like on the previous video, when we divided something with x squared, this would not work with synthetic division, only linear factors. So if I look at my first example, we're going to eventually do synthetic division, but we want to divide x to the fourth minus 3x squared plus 1 by a linear factor of x minus 2. So if I do this first based on the last video, if I want to divide x minus 2 into x to the fourth, don't forget your placeholders, plus 0x cubed minus 3x squared plus 0x plus 1, I would say, does x go into x to the fourth? Well, x to the fourth divided by x is x cubed. So I'd have an x cubed here, and then I'd multiply backwards. X cubed times x is x to the fourth. X cubed times 2 is negative 2x cubed. I am subtracting, so my signs change to minus and plus here. Combine down, 2x cubed minus 3x squared plus 0x plus 1. Does x divide into 2x cubed? Yes. If I take 2x cubed divided by x, that would be left with 2x squared. Now if I multiply back, 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. Things are lining up nicely here. Subtract, both signs change. Combine down, we would get 4x squared minus 3x squared is 1x squared plus 0x plus 1. Does x go into x squared? Yes, it does. X squared divided by x is just x, or 1x. Multiply back. 1x times x is 1x squared. 1x times negative 2 is negative 2x. Subtract. Combine. 2x plus 1. Does x go into 2x? Yes. 2x divided by x is 2. This is a long one here. So I'd get, multiply backwards, we'd have 2x minus 4, subtract, signs change, and I'm left with 5. Now x does not go into 5, so this is my remainder. So my answer with long division would be the quotient x cubed plus 2x squared plus 1x plus 2 plus the remainder of 5 over the divisor, x minus 2. So if we do it like yesterday's method, that would be the answer. If you're interested in the synthetic division, which I do feel sometimes is faster, if you think about this problem, if I'm dividing by x minus 2, if you think about the zero product property, that really means if x minus 2 equals 0, that my root is really x equals 2. So what synthetic division is taking this process and using only the numbers, not the letters. So what we would do is we would take the root of 2 and put it in a little box to separate it from all the other coefficients. We would look at the dividend and notice that there are really 1, 2, 3, 4, 5 terms in the dividend. The lead coefficient for the x to the fourth is 1. The lead coefficient for x cubed is 0. Then we have a negative 3 for x squared, a 0 as a placeholder for the x, and then a 1. And I'm going to draw a line underneath here, and I'm going to follow the same process that I was doing previously, which is why I have them next to each other. The best thing about the synthetic method versus the long division method, though, is because we actually have the root of 2, we're not dividing two polynomials anymore. So we're actually taking out the division part and focusing more on the multiplication and the combining down part that we were doing in the long division. So if we're thinking about the multiplication and combining down, what the process would be is this. we bring down the 1, and then we multiply diagonally. So 2 times 1 would get me the 2, which I put here. And then we combine again, combine down. Multiply 2 times 2 to get me 4. Combine down, get a 1. 2 times 1 is 2. Combine. 2 times 2 is 4, and then I end up with a 5. Now, this is really amazing because the answer that I got before was x cubed plus 2x squared plus 1x plus 2 with a remainder of 5. If you think about what we're really doing, we're starting with something with a degree of 4 and we're dividing a degree of 1. So it would make sense that our final answer has a degree of 3. So if we think about these as decreasing degrees, we could write this as 1x cubed plus 2x squared plus 1x plus just the number of 2, and then this number, just like the previous example, notice that we got a remainder of 5. Well, guess what? With synthetic division, we get a remainder of 5. So I'd still write this as 5 over the divisor of x minus 2. So synthetic division with a linear term that we're dividing, so we can easily find the root, is much faster. But long division is still very useful for anything that's higher than 1. So I just want you to recognize before we change slides here that the numbers that you have left over are all a degree lower than with what you started. So next there's something called the remainder theorem, which is also a pretty cool connection to the problem we just completed. If a polynomial is divided by x minus k, the remainder is r, which is also f of k. Now, what that means is, like the previous example, we divided x minus 2 into x to the 4th minus 3x squared plus 1. And so what this is saying is if you have a polynomial like this, the remainder r, which on the previous example we got as 5, is also the same as if I plug in f of 2. Now, where did I get the 2? Remember, the root that really comes from x minus 2 is 2. So what this problem is saying is if I plug 2 into my original dividend, then I should get 5. So let's see. F of 2 equals 2 to the 4th minus 3 times 2 squared plus 1, which would be 16 minus 3 times 4 plus 1. 16 minus 12 plus 1 is 4 plus 1, or 5. Check that out. So this remainder theorem is saying that at the beginning of the problem, if I want to know if this has a divisor, I could take my root, plug it into the original equation, and I would get the remainder of 5, which I did here. I took the root of 2, plugged it in, and got the remainder of 5. So do you notice anything from the previous two examples? Yes, I do. The remainder is the answer. The remainder of 5 is the answer to f of 2, which is really saying if I took x to the 4th minus 3x squared plus 1 and divided that by x minus 2, that means that the remainder that I get from here, which was 5, is the same as f of 2. Kind of cool. So if you want to see if something has a remainder at the beginning of the problem, you could just plug in the root and see. It helps determine if something's a factor or not. Which again helps me transition to the next example. The recap will be done in class tomorrow by your teacher. But if I'm looking at this example, given that x plus 3 is a factor of this, find all the zeros. Now, this problem is telling me that this is a factor. And if it's a factor, that means that my remainder must equal 0 because there should be nothing left over. So based on the previous slide, if I wanted to see if this has a remainder at the beginning of the problem, because this is x plus 3, that means that the root's really negative 3. I could plug in f equals negative 3 into here and get 5 times negative 3 cubed plus 18 times negative 3 squared plus 7 times negative 3 minus 6. And if I get this to be 0, it truly shows that it is a factor before I start. Or this could show that it should have a remainder before I start. So if I did this, this would be 5 times negative 27 plus 18 times positive 9 minus 21 minus 6. If I multiply the negative 27 times 5, I get negative 135 plus 18 times 9, which is 162, minus 21 minus 6. If I combine negative 135 and I add the 162, I get 27 minus 21 minus 6. 6 minus 6 is 0. Now, this is not really part of the problem, but what I'm showing you is that x equals negative 3 is a factor because I got a remainder of 0, or when I plugged negative 3 in. So unlike the previous example, I got an answer of 5, which means it's not a factor, but it does find me the remainder quickly. Now, if I want to complete this problem, it's saying, given this is a factor, find all the zeros. So what we would do is use the synthetic division, because notice that what I'm dividing by is a linear factor. So I would take negative 3, because I got that from here. I would write out all my lead coefficients, 5, 18, 7, and negative 6. There's nothing missing. I would draw my line, carry down the 5, multiply and combine, multiply and combine. So I'd get negative 15 when I multiply, combine down, negative 9 diagonally, combine down, positive 6, and I combine down, and there again is showing me that I have a remainder of 0. But I want to find all the zeros, or all the roots. Remember, all of these numbers are a power less than with what you started. We started with a cubic. This would be 5x squared plus 3x minus 2. And now what's extremely convenient is that we're left with something squared, and we just had an entire unit on finding zeros based on quadratics. So let's continue to factor this and set it equal to 0. Now this 0 is the remainder. This 0 is just to solve. These do not correlate. So if I were to factor 5x squared plus 3x minus 2, I could split the middle term for that. A times c is negative 10. Here are all the numbers that multiply to be negative 10. This pair would work to combine to get a positive 3. So I could split that into negative 2x plus 5x. Carry down the other terms. Grouping, take out an x, left with 5x minus 2. Here my GCF is just 1, and I'm left with 5x minus 2. So this would factor to be 5x minus 2 is one parenthesis, and what's left over, x plus 1 as the other parenthesis. So if I set these both equal to 0, my answers or roots would be 2/5 and negative 1, which mean the answer to my question, all the zeros, if I write them as points, would be negative 3, 0, 2/5, comma 0, and negative 1, comma 0. This last example, given x plus 5 is a factor of this, write the function as a product of linear factors. So what we need to do is first find all of the answers and then write it as a polynomial in factored form. Now this is going to take a couple steps. So I'm going to start this example in this video and finish it up in the next video. The next one will not be too long. So let's start it here at least. Given this is a factor, so that means because it's a factor, I already know that the remainder is 0, so we don't have to plug anything in. I do know that my root is really negative 5, so I'm going to use synthetic division to help find my other roots. If I carry down my lead coefficients, I'd have 1, 5, negative 18, and negative 90. So this is where I'm going to pause, and I'm going to continue this example in its completion in 8A.3 Part 2. Thank you, guys.